Alright, so today we will be writing polynomials from the zeros, which we did a little bit of yesterday when we were going over how to graph and things like that. So we are going to find different ways to do this. And by that I mean like when we're given the zeros in factored form, or when we have to factor and then get the zeros, or when we're given the zeros as a list, like a 9 and 10 at the bottom there. So I'm going to be doing the odds on this worksheet, and then your homework will be the evens. So on this first section is to find all the zeros, and that's what we're going to be doing throughout this worksheet. But on this first section, we're given our polynomial in factored form, our function. So this is in factored form already for us. So when we have something that is factored already and we want to find the zeros, we use the zero product property. And so what we're going to do is set each factor equal to 0. And solve for x. So we have 2x minus 1 equals 0, and we have x minus 5 equals 0. So I'm going to solve this first one, and divide by 2, and get x is equal to 1/2. And then on the right side we have x minus 5, so I'm going to add 5 to both sides. And I get x is equal to a positive 5. So when I'm writing my zeros, we can write them as a list. We can say x equals 1/2 and 5. We'll do the same thing with the rest of the odds. We're just taking each factor, setting it equal to 0, and solving for x. So on the first one, we get x is equal to negative 1/2. We'll take that second factor and set it equal to 0. Solve for x. X is equal to negative 1. And that third factor. And we will solve for x. We get x is equal to positive 1. So when we're listing out our zeros, we would just say negative 1/2, negative 1, and positive 1. Now in the next one, we've got quite a few factors. So remember that x in the front is a factor. Just because it doesn't have parentheses around it doesn't mean that we're not going to use it. So we would just say x is equal to 0, and we're done. Then x plus 2 is equal to 0. Subtract 2. X is equal to negative 2. Then the negative 2 we'll add 2. We get x is equal to positive 2. Now this last one, we've got 3x squared minus 4. So first we'll add 4. We get 3x squared is equal to positive 4. Divide by 3. We get x squared is equal to 4/3. We still need to take the square root of both sides. Whenever we take the square root of a fraction, it's the same thing as taking the square root of the top over the square root of the bottom. And so we get x is equal to plus or minus 2 over the square root of 3. So when we list out our zeros on this one, we're going to have quite a few. We've got 0, negative 2, positive 2, and plus or minus 2 over the square root of 3. And we're just going to leave that radical in the denominator for now. We're not going to rationalize. On number 7, same thing. We take each of the factors. Don't forget that one in the front will just be 0. We'll get x is equal to 1/2. we've got x minus 1 is equal to 0. Add 1, x is a positive 1. And then x plus 1 is equal to 0. Subtract 1. And x is equal to negative 1. So we have x equals 0, positive 1/2, positive 1, and a negative 1. Now on this next section, it says to write a polynomial function of least degree with integral coefficients that has the given zeros. We're going to write these polynomial functions in factored form. Because we did practice writing them in standard form on the homework yesterday. So when we're writing a polynomial function of least degree, that just means none of these have a multiplicity. So all have a multiplicity of 1. And so we have 3. We're going to take the opposite, so that factor is x minus 3. 2 gives me a factor opposite of x minus 2. And negative 2 gives me a factor of the opposite plus 2. And once I create a factor for each, then I am done with that problem because I've made my polynomial function. Still with the same instructions on 11 and 13. We're going to make this factor by taking the opposite. This factor by taking the opposite. And we know that a 0 is just an x. A lot of times you'll see the x written in the front, so you wanted to rewrite it and say x times x plus 1 times x minus 5, or x minus 5, x plus 1. It doesn't matter. Remember, order doesn't matter when we multiply, but most of the time you will see it like this, with the x in the front, since it's by itself. Now on 13, we have a fraction. So I know these will be the opposite. X minus 1, and this is x plus 1. But how do I find this one? Well, I can say x minus 5/3, and I know that equals 0. But I don't want a fraction in there. So what I can do to get rid of the fraction is I can make this, I think it's a little easier to see when it's just x equals 5/3. And I want everything on the left side with the x without the fraction. So I can't just move it over and say x minus 5/3. So I'm going to undo all of these operations. The first one being the division. So I'm going to multiply both sides by 3. I get 3x is equal to 5, but I still want it to look like equals 0. So I'm going to subtract 5 from both sides. I get 3x minus 5 equals 0, and then that is my factor. So when I'm writing my function, I have 3x minus 5, x minus 1, and x plus 1. On the next section, it says to find the zeros by factoring each function. So on these, I only want you to do number 16, because these down here, oops, there's my scratch work. These down here, the examples, some of them end up with really funky factoring, which we have not really gone over yet. And I don't want y'all to stress over that when our priority right now is just writing the polynomials. So we're not going to worry about the numbers 17 through 20. We're just going to stop with 15 and 16. So on number 15, we are finding all the zeros by factoring each function. On number 15, I've got x cubed minus 2x squared plus x. So what I want to do is find a GCF if I can, and I see that each term has an x on it. So I'm going to take that out and reduce each by an x. And I'd be tempted to stop there and say, well, I factored, but I still need to factor what's inside the parentheses if I can. So I'm going to try to factor what's in the parentheses. I've got x squared minus 2x plus 1. So I would need two numbers that multiply to positive 1 but add to negative 2. Two numbers are x minus 1 and x minus 1. Keep that x on there. Don't forget to bring it down. So that is my polynomial in factored form. And then I'm finding the zeros. So this is now just like that first section where we're given the factors and then we find the zeros from there. So we have x would equal 0. That's from the first one. And then I see that this is twice. So I'm only going to solve it once. So x is positive 1. And I know whenever it's written twice, whenever a linear factor is written twice, then that means it has a multiplicity of 2. So when we're writing our zeros, we would say we have 1 at the origin and 1 at 1 with a multiplicity of 2, meaning it would bounce right there at x equals 1. So again, I am cutting out 18 and 20 from your assignment because on 17 and 19 we had some weird factoring going on as well as some imaginary roots, and we're not going to get into that. So we're just going to stop on number 16. Just a heads up, number 16 is one of your special cases for factoring.